Hi, today we discuss chapter 6, angles and tangent of circle, sudut dan tangent bagi bulatan. Cuba perhatikan nota di sini. Alright, number 1. Before we discuss, you must understand the terms like circumference. So circumference refers to the circle here. The circle that we draw, we call it circumference of the circle. Okay. The first point is angles substandard at the circumference by the same arc are equal. When we talk about arc, what is meant by arc? Arc is a line that joins 2 points at the circle, like AB. So this one we call it arc AB. So from this arc AB, we draw angle at circumference. Angle at circumference means the vertice that we draw must touch the circumference. So this one we call it angle at the circumference, sudut pada lilitan. And this one also angles at the circumference. And this one also angles at circumference. So all these three angles coming from the same arc AB. So from these properties, we can say that all the angles that form at the circumference substandard from the same arc are equal. So semuanya adalah sama. If this one is 30, means all are 30. Okay, so this is what the first point, the properties of angles at circumference. Okay, number 2, angles substandard at circumference by arc of same length are equal. So let's say we have two arcs here, same length. If they are same length, so the angle of circumference substandard by the two arcs must be equal. So same length of arc produce same angle. Okay, so lengkok sama panjang hasilkan sudut pada lilitan yang sama. Okay, number 3, angles substandard at center by arc of same length are equal. So let's say O is the center of the circle. So if you draw a line of arc here, these two are same length. So when you extend or subtend angle to the center of the circle, so this angle we call it central angle. Okay, so angle which vertice touch the center, we call it central angle. So central angle same value if coming from the same length of arc. Okay, so sudut pada bulatan datang daripada lengkok yang sama panjang adalah sama besar. Okay, so central angle formed by arc of same length are equal. So this one same. Okay, number 4, angle subtended at center is twice the angle subtended at circumference by same arc. Now we want to relate between angle at circumference and central angle. So if they are coming from the same arc, this central angle and this angle of circumference, so we can say that angle at the center is 2 times angle at circumference. Okay, maksudnya begini, kalau dia datang daripada lengkok yang sama, maka sudut pada pusat adalah 2 kali sudut pada lilitan. Or we draw like this. So also coming from the same arc. So central angle is 2 times angle at circumference. So ini daripada lengkok yang sama, so sudut pada pusat 2 kali sudut pada lilitan. Okay, or we draw like this. Okay, we have major arc here, major arc. Okay, so this angle we call it central angle. This one is central angle. Okay, so central angle is 2 times angle at circumference. So you can see here, this one is x, so here is 2x. Okay, okay, so central angle 2x, angle of circumference x. So number 5, angle subtended at circumference in semicircle is 90 degrees. if you draw a line, or like you draw a diameter. Diameter is a line that passes through center of the circle. So here it will form semicircle, two semicircle. So whenever you draw a triangle, okay, a triangle in the semicircle, which the vertices touch the circumference, so the angle at the circumference is 90 degrees. Same thing if you draw here. If you draw here also 90 degrees. Okay, if you draw here also 90 degrees. So angle substandard at circumference in semicircle is 90 degrees. Okay, same thing if you draw this side. Okay, if you draw this side, here also 90 degrees. Okay, so sudut pada lilitan dalam semi bulatan ialah 90 darjah ya. Jadi kamu kena ingat semua point ini ya. So you need to remember all the properties in order to answer all the question. Okay, next. A cyclic quadrilateral is quadrilateral whose vertices lie on the circumference of the circle. So cyclic quadrilateral, you can see here, if we have 4 vertices here, let's say this one is A, and here is point B, here is point C, and here is point D. So meaning all the 4 vertices A, B, C, D must touch the circumference of the circle. Okay, all must touch. If one does not touch, that one is not cyclic quadrilateral. Okay, let's say all the interior angle, so sudut di dalam kita panggil interior angle, we mark as A, B, C, D. So the sum of interior opposite angle in a cyclic quadrilateral is 180 degrees. Hasil tambah sudut pedalaman bertentangan ialah 180. Maksudnya macam mana? Okay, contohnya this one, A and C A and C are opposite angles in cyclic quadrilateral. So we total up A plus C, we get 180 degrees. Same thing, B and D. Okay, B and D are opposite interior angle. So B plus D equals 180 degrees. Okay, next, number 8. The exterior angle of cyclic quadrilateral is equal to its interior opposite angle. Okay, this is a cyclic quadrilateral. If you extend one of the side, so it will form one angle outside here. We call it exterior angle. Okay, so for this straight line, if this one is exterior angle, meaning inside here is interior angle. Okay, the corresponding interior angle. So according to these properties, exterior angle of cyclic quadrilateral equals to its interior opposite angle. So opposite to this interior angle is this angle, X. So meaning Y equals to X. This is what stated by this statement. Exterior angle is equal to interior opposite angle. Okay, so Y equals to X. Okay, ataupun kita boleh sebutkan sudut peluaran, sudut di luar adalah sama dengan sudut pedalaman ni yang bertentangan dengannya. Okay, yang bertentangan dengannya, maksudnya X. So kita boleh sebut X equals to Y, ataupun X adalah bersamaan dengan Y. Or in other words, you can do the same thing here. You can extend the line here, so it will form another exterior angle. Let's say we mark as angle P. Okay, so if this angle is, let's say, is S, so this is the exterior angle, this is the interior angle, so opposite, okay, to interior angle, meaning P equals to S. Okay, Same thing. So you must understand the properties. Okay, next we look at the tangent. Tangent actually is a line that pass through only one point at the circle. So look at here, just pass through this point. Let's say point A. Just pass through this point A. So this line we call it tangent. If you extend a line from the center to point A, so this one is the radius of the circle. So radius and tangent always 90 degrees to each other, perpendicular to each other. Okay, now let's say we draw two tangent pass through point A and point C, and the two tangent intercept at B. Okay, kita ada dua tangent sambung garis dan dia akan bersilang pada titik B. So we can say AB equals to AC. The length of AB equals to the length of AC. So if you draw from the center to point A, this one is radius. You draw from point O to C, this is radius. Radius and tangent 90 degrees. 90 degrees. Okay, so what are the properties that we can see from here? So the radius like OA of course equals to OC. AB equals to CB. So I draw line here to join OB. So we can say these angles also same. These angles also same. So you must understand the properties in order to solve problem. Okay, the next one is when we draw, let's say we have a triangle here in this circle. So this line that pass through 2 points at the circle, we call it chord. Okay, chord. So when you draw chord and a tangent, the angle here A is like an exterior angle. So this exterior angle is equals to opposite angle to the chord. So meaning angle A here. So opposite to the chord, to this chord, this chord is angle A here. So meaning angle here is equals to angle here. So angle B here for this chord, okay. So we have for this chord, okay, is angle B, angle B. So this one is equals to this angle, okay. So exterior angle equals to opposite interior angle, okay. So here A and here also A. If here B, here is B, okay. Okay, common tangent. Common tangent means we have two circles. When we draw tangent, they share the same tangent. Let's say we draw 4 tangent at point A and B. Okay, this one, the tangent will pass through 1 point at both of the circles. So we have tangent ABC, and then another one at the bottom here, EDC. So these two tangents, we call it common tangent because shared by the two circle. Kita panggil dia tangent sepunya sebab disambung pada dua bulatan yang sama. Okay, so this one we call it common tangent. Same thing as AD and EB, also common tangent. FI and HG, also common tangent. So we have 4 common tangent: ABC, EDC, FI, and GH. Okay. So point OMPC are in line or collinear on the same line. Okay, OMPC, so they are collinear. Okay, so from here we can say AB equals to ED, same length, and FI equals to GH, okay, same length. Okay, next we have when the two circles, there's an overlapping, the small section of the two circles are overlap. So we can say there are two tangent, common tangent, ADB and CEB. Okay, so from here we can say AD equals to CE, DB equals to EB. okay, same line, and point OPB are collinear. Okay, so this one of course 90 degrees here, angle. Okay, now we have overlapping. The small circle is inside the bigger circle, so they only have one tangent here, RBS. So the point AOPB, AOPB are collinear. So O is the center for the bigger circle, P is the center for the smaller circle. So mean all these are the properties of angles at a circle. So if you know all here, all the properties, either you memorize or you can understand it by doing a lot of exercise, so you can solve problem easily. Now we look at some of the question. Let's say we have the first part. It's a very simple exercise for the first part using the first property. So from here, the relationship between central angle and angle at circumference. Okay, so from here we know if they are substandard from the same arc, so meaning central angle is 2 times angle at circumference. So the relationship we can write A equals to B. Okay, so from here also can central angle M, angle at circumference is N, meaning M equals 2N. And or we have this one for this arc, the major arc. So central angle is R, so R equals to 2S. Okay, so this one also you must understand, R equals 2S. Okay, so here is M equals M equals 2N. Okay, 2 times. Okay. Okay, this one also same. The problem solving involving a central angle. So same length of arc. So central angle are same. So meaning x equals to 50. And this one same length of arc also. So x equals to 43. And this one you can see the length of the arc double. So meaning the circle here is double of the circle. So meaning x equals to 140 divided by 2. So you have x equals, so you have x equals 140 divided by 2. So you will get 70 degrees. Okay, so it's one of the problem solving. Okay, this one is for the triangle in the semicircle. So what is x? Let's look at J. So all the angle of circumference is 90 degrees. So x equals to 180 minus 90 minus 35. So we have x equals 90 minus 35. Okay. So you have the answer is 55. Okay. So the answer is 55. Okay. Okay, you again because not very clear. Five degrees. Okay. So problem solving also, you can use all the properties that you discussed before. Let's say we try for D here. So look at this arc. So we have two angles that subtended from the same arc, X and 65. So meaning X equals to 65. And then if you look at the triangle, this triangle is the triangle in semicircle. So the total angle here 90. So where is the answer for Y? So you have Y equals to, so 90 minus 65. So you will get 25. Okay. So this is how we solve one of example. Okay. So you can try more on this question. Look at cyclic quadrilateral. Okay, find the value of x and y in the following diagram. So we have discussed before, cyclic quadrilateral, all vertices must touch the circumference. So the opposite interior angle, the sum of opposite interior angles equals to 180. Okay, so what is y from here? Meaning 180 minus 85. So you get 95. Okay. And then what you want to find x, same thing. Total of x and 110 equals to 180. Thus x equals to 70. Okay. So you can try more on this question. Okay, B. You have exterior angle here. We have discussed exterior angle equals to opposite the interior angle. This is interior angle. So opposite to this angle is y. So meaning you can say y equals to 70. And then x equals to, this is the interior angle. So opposite to interior angle is this angle. So x equals 125. Okay. Okay, you can look at this question, for example. Find x plus y. So x plus y, this one is a cyclic quadrilateral. So x is the total angle here. Okay, so you can find what is this angle first. This is also cyclic quadrilateral. PQRS is cyclic quadrilateral. If here is 130, meaning QPS equals to 50. So you can try to find x plus y equals to what? Okay, meaning x plus y equals to 180 plus 50. Okay, so you get x plus y equals to 230. Okay, so you can try this one. Find this one first, and then we have total angle here. X plus y is, this angle, these two angle, total up, you get 180. So you need to plus one more here, 50. So 180 plus 50, 230. Okay, one more question about the common tangent. This one. Okay, let's say we try one question. Solve problem involving the tangent, common tangent. or tangent to the circle. So let's say we try B. Okay, so X is point here. So this one we call it cyclic quadrilateral. So you can find X first. So X equals to 180 minus 115. So you get X equals to 65. Okay, so you want to find what is Y. Okay, so you find Y and then you can solve the problems. Okay, so that's all for this topic. We will discuss more on this problem solving about the common tangent and other examples or your PT3 exam sample question on this topic.